Joining. Hi, folks. We're for those of you who joined right now, we're going to get started in just a few moments. Let some more people jump on, but thank you for joining, and yeah, appreciate it. I know that Vasuntara is the second event this week, I believe. So nice to see you again. Thank you for being a loyal joiner of our events. Appreciate it.
It's really fun to be participating in these conversations. I learn a lot, so.
It's great. Happy to hear it. Okay, so give it a few more minutes. Okay, we can get started and people can keep filtering in, but thank you all for joining. I'm Michael Martin. I lead the communities program here at SignalFire. You may have seen my name in your inbox or communications otherwise. So I appreciate you answering the email and deciding to join today. SignalFire is a VC firm. We invest in early stage and later stage startups. Today, we're going to be focusing on one conversation that's related to one of our startup companies, as well as friends of that company, Blue Bracket. Ajay Aurora is our moderator today from that team. And we're lucky to be joined by Jim and Aparna as well, who will be participating in the conversation high level on securing the software supply chain. We have a bunch of great questions lined up on our side for these folks. And sorry. With that, though, I will ask if you all have questions throughout this, please type them in the chat and we will address them as we go through the conversation. We'll have a stop at around 10 a.m. And we can bring in some questions there, and then we'll just keep asking them and we'll address them throughout the conversation and specifically at the end. So with that, I'm going to turn it over to Ajay, who can then take it away from here.
Thanks so much, Michael, and thank you guys at SignalFire for hosting the event. And I'm going to go ahead and I have the pleasure of being able to introduce our speakers here that I'll be monitoring as well. So I'm moderating the discussion with, and excited to do that. As we begin, if you don't mind, this world of Zoom, while you're in kind of listening in mode, and we'll get to questions later, if you don't mind muting your mics, and then we'll take questions in a bit. If that's not a problem. But thanks so much, and I'm going to introduce our speakers here today, and I'll introduce myself a little bit as well. But really, we should just jump into the topic. So, earlier this year, the FBI sent out a warning of ongoing hacks to what we're calling the software supply chain. The criminals who are responsible for these hacks are using the supply chain to insert vicious malware that can be exploited unwittingly by companies who use code. With over 90% of applications containing open source nowadays, this is clearly an issue that affects everyone. Luckily, we have two tech leading minds in this arena here to tell us what to do and guide us in this overall pursuit. So I'm pleased to introduce Aparna Sinha, who is the Director of Product at Google Cloud for Application Development Platforms, where she's focused on faster, safer software delivery. Aparna has helped grow Kubernetes into a widely adopted platform through her role at Google and as chair of the Cloud Native Computing Foundation governing board. She holds a PhD in electrical engineering from Stanford and has worked in enterprise software for over 15 years. So clearly, I'm definitely not the smartest one in the room here by a long shot. And is widely acknowledged as a strategic thought leader in the world of enterprise software. So really pleased to be able to have Aparna here this morning. I think she's going to be great, for this discussion. And also joining me is Jim Zemlin, who is the executive director of the Linux Foundation, which is a nonprofit organization responsible for Linux, but also many other key technologies such as Kubernetes, Node.js, and about literally 100 more. Jim has personally created projects like the Core Infrastructure Initiative to strengthen and support open source security. Jim sits on the board of the Global Economic Symposium, Open Source for America, the Chinese Open Source Promotion Union. And so along with many, many other accolades, and speaks around the world often. So very pleased to have Jim on board as well. And I'm going to be your moderator today. I'm Ajay Arora. I am the co-founder of Blue Bracket. We are a company that is focused 100% on securing source code visibility and compliance and security for all things source code, especially in Git environments and in open source. I've been cybersecurity and a serial entrepreneur, kind of glutton for punishment for a number of years now in the cybersecurity space. And so I'm really excited to have this conversation. So please, join me in welcoming Jim and Aparna. And I think we should just go ahead and dive in after those introductions. So I think we let's define our terms a little bit, and let's start to make sure that we are talking from the same page. So let's start with the definition. So Jim, can you talk about first about what you consider the software supply chain, and what are its most important elements? And then we'll ask Aparna the same question.
Yeah, I mean, this is something that we've thought a lot about at the foundation as we're examining ways to collectively improve cybersecurity for really everybody who participates in the technology ecosystem that's in particular dependent on open source software, which is essentially everyone. But I think when you think about the software supply chain, it's important to understand how code flows from an upstream repository where a developer is writing software, and in many cases collectively, either with an internal team inside of an organization or across organizations in an open source project. And today it's across countries, across companies, from individuals to everything in between. That code then is packaged up, and today there is an important part of the software distribution mechanism, which are package management systems that essentially distribute this software in a secondary layer. These are dependencies that people pull in as they're building modern applications, whether it's in the cloud and so forth. And then there's the end of that supply chain, which are organizations like Google that offer software as a service through their cloud product, or through an embedded device, maybe an Android phone or an iPhone, where that software then eventually comes in contact with the user. That software supply chain is incredibly complex and has become more complex as the amount of software required to solve big problems has grown. Just to give you a flavor of what the supply chain looks like, just in Linux Foundation projects, these are only the 450 odd projects that we host of the millions that are on GitHub. 31 million lines of code were added last week. 20 million lines of code were removed. There are 236,000 developers in our development community from 19,000 different organizations. This represents 1 million pull requests, 12,000 repos, 4 billion container downloads, 200 million builds. It is a incredibly fast moving, complicated supply chain. I think the important thing for people to understand is at each point in the software distribution supply chain, do you, either as a distributor of software or a consumer of software, have a good handle on what code am I depending upon, who is writing that code, and is that code written in a secure manner that I can rely upon? And I think those are really tough questions due to the great complexity of the global software supply chain.
Yeah, I mean, those numbers are mind-blowing at some level, mind-boggling at some level to think about that there's so many moving parts and then so many, as you mentioned, pull requests, et cetera. So Aparna, from that perspective, if you want to maybe from your perspective also help define what you view as the software supply chain, and also more specifically too, what keeps you up at night related to the supply chain in terms of overall security. There's been a number of different high profile cases like Heartbleed and others. And so what other common scenarios are you seeing out there that people should be aware of in terms of the software supply chain, how you view it, and then how to secure it and where the kind of the weak links in that chain?
Yeah, thanks, Ajay, for the question. So I'm at the intersection of open source and, of course, working with customers in my role at Google. So when we think about security in general, there is the interaction of the software supply chain with the infrastructure and with the application users that the customer has. So I typically think about it in 3 layers. There's the security of the infrastructure, which is what you want to make sure that there's isolation of the right kind at the network level and at the container level. Then there's the software supply chain, as Jim described it, which is where's your code coming from? What are the dependencies that are embedded in that code? And what are the checks that you have in place to make sure that that's not going to lead to some sort of vulnerability or interact with your infrastructure in a way that's against your policies. So that's really, there's the software supply chain, and then what kind of controls can we give our customers to make sure that they're always secure. And then the third layer is really what we call runtime security, is what sort of threats are in play, bad actors, that are trying to get into your application and misuse it in some sense. So those are the 3 layers of security we think about in cloud from a customer perspective. And, you mentioned Heartbleed. These are some of the things that it's the interaction of the infrastructure and the software. So we do try and take a more holistic look across all of these layers. And what keeps me up at night is ensuring that we have given our customers the visibility and the controls that they need so that they can set policies that prevent any type of breach in what they need to deliver to their end users. I feel very confident about the scanning capabilities that we have and the upstream work that Google does in general. We do a lot of that to prevent our customers from getting impacted by vulnerabilities, things like Heartbleed and others. We do work very closely with Jim and the open source foundations and the open source communities to know ahead of time and to patch that. But I think when you're using software outside the cloud, you don't have that as much. And so that is something we try and make sure that our customers have the controls in place and have the visibility to things that could impact that.
Yeah, I know. So great. So just to follow up on that. So, you as Google obviously have numerous resources at your disposal to be able to offer layers of security. So as you both pointed out, it is a supply chain. And so there are smaller and there's bigger players along the way. So what is it that you see in terms of what's outside of your control? So especially for companies that are, or individuals that have to rely on the safety overall. Google obviously controls an ecosystem of that. Linux Foundation has a number of resources to be able to tap into or advocate. But for smaller organizations, smaller contributions, how is it possible to be able to look at this holistically and identify where is so-called the weakest link, or be able to surface it and be able to address that as it grows more and more complex? Any ideas on that, Purna or Jim?
Sure, I'll take a quick pass at it and then turn it over to Jim. So we try and provide the tools that customers can use, but we have this model called the shared responsibility model, meaning there are certain things that are the responsibilities of the provider, and then there are certain things that are the responsibilities of the developer or the customer themselves, right? So you are writing code, you are deciding what dependencies you're taking, you're deciding what language you're writing that code in, and you're deciding on the deployment model. We try and provide the tools to make sure that the infrastructure is secure. Increasingly, we're working on software supply chain security, which is helping you know whether the appropriate licenses are in play, helping you know that the code has been scanned, helping you know that there isn't some sort of code that shouldn't be, that isn't allowed by your organization deployed into a certain environment. And this is where we partner with many companies like Blue Bracket, to provide additional services. ultimately this is the part of shared responsibility that is upon the customer, because their application is their application. So they have to choose to use these services and make sure that they have the security stance they need.
Jim, thoughts on that in terms of
Yeah,
like,
I mean,
services
I
that we
would
just
agree
looked at?
with Aparna, and you know, there are layers of responsibility. I mean, I would point out that under Aparna's leadership, the Cloud Native Computing Foundation conducts regular, you know, hands-on security audits of major code bases there. I mean, these aren't just, you know, static code analysis. These are third-party audit firms that come in and make sure this code is secure, because this is a project that so many people are dependent upon, one of the most critical projects in the world. I think for small organizations, the thing we're seeing at the foundation now is a need for people to have situational awareness. Just like, you know, 10 years ago, everyone, you know, what's your network perimeter? Make sure you have a firewall, you know, have your anti-spam tools, have a security policy around that perimeter. Well, today, a major attack vector is application vulnerabilities that come from bugs or mistakenly putting credentials in code and so forth. And small companies need to get their arms around this, because the consequences of a, you know, cyber intrusion or disclosing people's personal information and so forth are quite severe. And as a result of that, what you've seen is a huge growth in the entire software composition analysis and security tooling industry. Dozens of startups, companies like Blue Bracket coming in and helping organizations quickly understand what code are we dependent upon, both within our organization and stuff that comes from outside of our organization. Are there secrets in that code? You know, who is, you know, having access to the different repositories that we use to build the tools that we're deploying, whether it's on a cloud service provider or on premise. That there's an entire industry that's coming up, and I think you're going to see more and more of that as we see, in particular, high-profile attacks, you know, such as the OpenSSL Heartbleed bug, you know, the Equifax intrusion was a big one. I think what we all have to do is work together, and Google recently worked with us to create something called the Open Source Security Foundation. This are the security teams from Microsoft, GitHub, IBM, Intel, you know, Red Hat, Google, and many others who are looking at, let's figure out what these emerging security threats are. Is it people coming in and do man-in-the-middle attacks on package management systems? Is it unintentional exposure of secrets and code from companies that are participating in large open source projects? Aparna pointed out, tooling is critical. We need to provide developers both upstream and small companies that, you know, are you know, going through a digital transformation process with tools to do security scanning, software composition analysis, you know, and understand where vulnerabilities lie. There's a whole set of best practices that we need to roll out there. We just did a research study with Harvard Business School's Lab for Innovation Science. We asked the developers who write the most widely deployed software in the world, the maintainers of those projects, about 2,000 developers, you know, how do you spend your time? And writing new features was number one, and dead last was working on security. And so we need to figure out how to change and create a culture of secure code responsibility. We need to have better ways to escalate vulnerability disclosure. We need to do digital identity attestation across the software supply chain. And then we need to figure out what these important shared projects are, like a Kubernetes, and do the kind of things that's going on in that community: third-party audit, constant dynamic and static code analysis, using modern security tools in those projects themselves. That's where we have to head towards.
So great point. So, you know, to that effect, okay, you know, you named a number of different areas, both of you, that are critically important for the software supply chain. And so ultimately, though, it's like herding cats. So who bears the responsibility, the bulk of the responsibility for enforcing it, how does that going to come to be? Because if you're entrepreneurs at small companies and you have developers that are coding away, as you very much pointed out, their job is to get the code out the door, not necessarily, they sometimes, while it's shifting left, so to speak, in terms of security, what are the incentives or the penalties that will have to be put in place to enforce this? And who bears the responsibilities? Is it the open source projects and foundations? Is it the larger, providers like Google or GitHub or GitLab or Bitbucket or any of these people? Is there a hierarchy of responsibility here? And then how do you make sure that it gets passed through? Is it going to be through incentives? Is it going to be through other kind of penalties? Any thoughts on how you heard these cats establish a responsibility and accountability framework? Because I think that's a big issue in terms of being able to identify, especially when there's so many pieces in this.
I'll let Aparna answer, because I do think Google has a very good hierarchy of how they define what's responsibility for a service provider, what is your responsibility as a developer of your own applications, and then I can maybe talk about the broader shared responsibility across organizations.
Wonderful.
Yeah, sure. Yeah, we have a pretty clear shared responsibility model, that I touched upon with the users. I think that security is an area where there's a lot of benefit from collaboration, and there is built-in incentive, certainly for the cloud providers, but also for those that are contributing to and writing open source software. And the built-in incentive is that, if there is a vulnerability, ultimately what ends up happening is it ends up costing everyone a lot of money, because there's a lot of time and effort that's spent in, mitigating an issue once it occurs. And there have been, these kinds of issues across all clouds. So there's definitely, I think, when we've worked with other cloud providers, this is an area where there's interest in, let's make sure that we have a way to identify vulnerabilities, share those, mitigate them, and to contribute to open source to prevent those and build in mechanisms. Certainly in the Kubernetes project, that has been the case, where we've had very good collaboration, building in mechanisms, all the way starting back from RBAC. And as Jim mentioned, the security audits that we've been doing, those provide customers a view of what the vulnerabilities are, and then also provide the project areas for work where we can improve those vulnerabilities and put in mechanisms to prevent them. So I think security is an area where there's been a lot of collaboration.
Yeah, I agree with that. It's certainly positive to see so many folks in the industry being proactive about trying to not only make sure that they're releasing secure code, that they have good application security practices, but then sharing those practices back upstream with the open source software that we collectively depend upon. So that's certainly a incredibly positive sign. And you see these organizations investing a lot of resources in it. I think the collective responsibility is something that is going to be tricky, and is maybe instructive to look back in time to when Windows was sort of the de facto standard around the world, and where, for many of you who are old enough may recall, Windows NT had these tremendous security vulnerability problems back in the early 2000s. And Bill Gates stopped all software production at Microsoft, wrote a letter to all of his employees and said, we're going to no longer create new software. We're going to go back, test all of our code. Everyone's going to take secure coding practice. We're going to, do threat modeling. We're going to lint the code. We're going to make sure that we have a rigorous application security process in place. And I believe the implication in the letter was, if you don't do that, you're fired. The issue we have in an interdependent open source world is that the only person that I could technically fire is Linus Torvalds, and that's pretty much a stretch at the Linux Foundation.
Right.
I'm not sure I could do that, but what you have to do is create a set of incentives for secure coding practices and a culture of shared responsibility. And I think we touched on it before. That means supplying developers with tools that enable them to test their code more efficiently, to be able to find vulnerabilities, to have suggested fixes, to be able to share vulnerabilities more effectively. The secure tooling is something that we all need to take seriously. I think my biggest concern around this collective responsibility is that if we continue to have high profile cyber attacks that result in wide scale, publication of people's, financial data, or, attacks on critical infrastructure, in the energy grid or wherever it might be, what we may be faced with is a regulatory intervention. You already see work at the FDA, as an example, looking at requiring a software bill of materials attestation in medical devices. You're going to see more of this, and I think that one of the things that we all need to collectively understand is that sometimes policymakers who may not understand the complexities of a global technology industry could overreach. And then that would reduce one of the great things that happens in a global supply chain, which is the free, and organic flow of ideas and collective innovation that you get out of it, which far exceeds the security risk, which I believe we can address through tools, processes, and a culture shift.
Great. No, wonderful. So a follow-up on this. So you mentioned the example of, Bill Gates saying that, hey, if you release code, or if you're not careful about it, your job could be on the line. But as we mentioned earlier, and let's get a little bit prescriptive here. As you mentioned earlier, about 90% of code now out there, or so estimates are, that have open source in it. And in your own census on software supply chain security that came out of the Linux Foundation, you found that many of the top projects are actually linked to individual developer accounts in open source. So, with that said, even if companies have like robust governance in their pipeline, what if the open source components are compromised themselves? And how do you ensure, when there's such a large or vast number of developers out there that are contributing to this, and even if you're a company the size of Microsoft, what are the best strategies or practices that you can actually point to or recommend, and being able to, you referred to the bill of materials, ensure that each of these components of the bill of materials themselves are not compromised? So best practices, tools, technologies to be able to do this, as no one starts with a blank slate anymore. They will not, the beauty of Git is that you don't have to start any project now, whether you're doing custom code or development, from the ground up. There's pieces that you can pull on and you pull from. So how do you ensure that that it's secure from the individual developers that are contributing, from the open source, from the custom code that created internally? What are some of the best practices, strategies, tools that either of you you can point to and maybe recommend to the people listening here today?
Yeah, I could try and take a crack at that. And I think it's also actually, my response will be related to your question about incentives as well. Who has the incentives? So we talked about how expensive it is when something goes wrong. And also, I think it's important to realize, from a customer's perspective, they're really trying to develop applications quickly and deliver them to their market, and their business depends on it. And that's increasingly true, I think, especially with the economic slowdown and the pandemic. Everyone has realized, across enterprises and small companies, that the ability to change and deliver new applications, maybe through new channels, to reach new consumers, maybe online channels, etc., is super, super important. And so what ends up happening is that if you don't have control and guarantees about the security of your software supply chain, ultimately your software supply chain is a lot slower, which ultimately impacts your top line. And so I think there's a set of incentives that end users have, of course, to make sure that they've got the checks and balances in place. And so that incentive then leads to adopting the right technologies. That could be a set of technologies that you adopt from a cloud provider, or it could be a set of technologies that you adopt from the ecosystem that's around, right? So that opportunity is available for cloud providers. It's also available for a number of startups, and you'll see in the security space not just the container security space, but in the general security space and in the open source security space, there's a number of different companies, startups that have that offer this value because customers want it. And so customers can select from that. I think in terms of, you asked about best practices, you know, as a provider of open source, someone that is offering managed offerings, obviously we make sure that, you know, that is secure, because that's the expectation. You know, you have an SLO with someone who's providing an open source offering. That means that that has to be secure. They're taking care of security. They're taking care of patching. They're taking care of upgrades, making sure that it's fully, you know, fully tested and all of that. But also it's up to the user to use the defaults. So typically we make sure that the defaults are the most secure. So you can kind of go in with your eyes closed and you use the defaults, and that puts you in the most secure posture by default. But then if you stray from that and you want to use something new, something different, maybe something that's in alpha, that's where the tooling and the ecosystem comes in, where you rely on that. And then lastly, you know, and we've been discussing this, there's a lot of passion certainly at Google, and I think also at other cloud providers in engineering to go and do the work in open source. So fundamental work, like to improve the capabilities of the Go language, for example, to detect, you know, vulnerabilities, to detect dependencies, to shift left, to help developers shift left on those. And of course, the other open source projects as well. You know, the Envoy project, which is helping with this, and the Kubernetes project. So those are the kind of prongs of work that happen.
Yeah, I agree with that. You know, you beat me to the punch on vendors do play a critical role in this ecosystem. If you look at companies like Google, Red Hat, you know, Microsoft, Amazon, you know, you sign an agreement with these organizations who are packaging this open source software along with software that they may write, and you have an indemnification agreement with them, and you know they are taking responsibility for a certain amount of the risk and responsibility for security. Not everything, but it certainly is something where an organization that has less resources, that's a great option. I think the general rule is understand the entry and egress of code, like what comes into your organization and then what is distributed either through, you know, a web application or a customer application. Companies need to get a handle on that. Users really need to do that. And you have at the most sophisticated level, organizations like Google and other cloud service providers that not only do that pretty darn well. I personally know, you know, people like Jim Higgins on the security team at Google who are, you know, probably the best in the biz. But they take it to an extra level where they're getting together and saying like, okay, we have a good handle on what we're using in production. We're on the line with this for our customers. And in order to get maximum leverage in terms of a security return on investment, we're going to work with our competitors even in these upstream projects to, you know, go and figure out what is the most secure code in the, what's the most widely deployed software in the world, what's the software that we all depend on commonly, which turns out to be not a massive amount relative to the millions of open source repositories out there. It's actually a pretty small number comparatively. Who writes this stuff? And is it written in a secure manner? And where we find the intersection of everybody depends on it and totally screwed up, we're going to go and assist those projects. And that's what they're doing in things like the Open Source Security Foundation. And then they're going to those individual maintainers, whether it's the folks in the OpenSSL project, people who are working in the Node community that are working really hard on packages that we all depend on, and offering them these commercial tools, you know, something like a Blue Bracket, you know, other tools that Google has developed for static and dynamic code analysis, fuzzing, you know, Google's done an amazing amount of job on fuzzing work and helping them create better code. And I think you're going to see more and more and more of that. Because, you know, if you think of, you know, the upstream as, you know, sort of that spring up in the mountains where that pure water comes, and if we can keep that pure all the way down the supply chain to, you know, the people who are drinking the water in big cities, that's going to be a much better investment than, trying to, fix all the plumbing after we find lead in the water. That's not good at all.
Yeah, no, that's wonderful. Great answers here, and it flows into. There's some really good questions that are coming in through the chat, and actually getting pretty specific around this as well, and things that we haven't touched on. So I'm going to jump into some of the questions coming from the chat, and thank you guys so much for adding to it. And if you have more questions, please pour them into the chat, and we'll address these now and make sure we get them all in. So from Brendan, here's a question. I'm going to read it as it came in. Hey, regarding digital identity attestation, I've read of incidents where malicious updates have been pushed through legitimate package managers by using forged signatures on the malicious code. How have bad actors been able to compromise signing keys in the past, and what can be done to keep it from happening? I mean, this is a great question because companies are relying on the integrity of these package managers to be their source of truth, or the source of getting what they feel is a safe code into their own environments. So if these are compromised, what can people do about this? How do we know that we should trust these package managers? Aparna, Jim, whoever wants to jump in here, please feel free if that question made sense.
I think Kim in there already. There's somebody I think in here from GitHub who are already working on that. I mean, I remember talking to some security researchers about this a while ago, and asking, what's the one thing we can do to help prevent these type of hijackings? And I mean, the answer is really, it's not one thing, it's kind of everything. And so one, maintainers have to understand that they will and could potentially be targets for social engineering attacks that I think are, I think it's Kim pointed out, that's a very common attack vector. I think we also, and you see companies, organizations like GitHub, Atlassian, other tool vendors really upping the game to have better systems in place to prevent people from breaking these things, all the way up to are we quantum ready in terms of being able to protect these incidents from happening. And so I think it'll just be a collective thing there. But I do think that Kim hits on a very common vector, which is that maintainers need to understand that they're going to be targeted with some of these, sort of social attack vectors.
Yeah, no, so that's a good point. So one question that this kind of leads to, I mean, Aparna, you can address this as well, is that of course GitHub has done some amazing things in this regard, but Git, as you know better than anyone, Git is a protocol and not a single product. And there's GitHub, Bitbucket, GitLab. There's a number of other long tail Git providers. There's a number of package managers. What do you see in terms of standardization and being able to achieve a standard in this? And Aparna, maybe if you can talk to how you see that maybe forming, or if that's even a possibility to come to some kind of set of standards that everyone agrees to from this regard.
Yeah, well, I mean, not everybody is on Git yet. The reality is that
right.
When you look at enterprise, there's still older systems in play, and that's where a lot of their code is. But in all the conversations that I've had with customers, there's clearly a movement towards Git, and sometimes that's happening in conjunction with the movement to cloud. Other times it's just happening on-prem because it is a more modern way of collaborative software development. And so I think that is certainly a standard that's emerging, regardless of sort of which vendor or which provider, which Git you choose. Sometimes it's something that you may choose to host yourself. There are many open source offerings available. In general, I have seen a concern, certainly in enterprises, about I've got to make sure that this is something that I have control over, because my code is my crown jewels. And so it's something that I need in a private environment. It's something that I have full control over even when they do adopt Git. So I think that is one thing. then many times you're using multiple Git repositories, or you're using them in different environments. And so I think there is a opportunity to provide security, scanning and other capabilities for multi-repository management that will both enable more secure software supply chain, as well as more automated software supply chain. And there's a number of efforts in that regard, both within Google Cloud as well as in the ecosystem, to enable customers to manage multiple Git repositories, possibly from multiple different Git operators, but have a common mechanism for scanning their code, common mechanism for replicating their code, common mechanism for automating their pulls, and putting policies around that. I think one thing we haven't really discussed is the policy piece, which is a critical piece, because you can't always guarantee that the code is perfect. There's going to be problems in it, but if you've got the right checks in place to prevent it from getting into production where it can harm you, then that's a big win.
I know that's great. So you touched upon something. Yeah, sorry, go ahead, Jim. Go ahead, please.
No, I mean, I think when you talk about standardization, and I'm not like a complete, Google, sycophant here, but like Google has also done some good work on this one with their Tecton project, which is a part of the CD Foundation at the Linux Foundation. So this is a standardized way of doing CI/CD tooling and processes across vendors, languages, deployment environments. Works with, Jenkins and other popular CI/CD tools. This is another component where you're going to see security standards being implemented, not only in Git and in, package management systems, but across the whole CI/CD pipeline. And Tecton is one worth checking out in terms of where these things are emerging. I think there's some really interesting work going on there. I think, if you take some really extreme examples, and this is again where, if this becomes a big enough problem, one of the things that we've spent years trying to do, it's almost open source archaeology where we're trying to figure out who are these people actually. And it turns out getting the actual identity of a lot of folks who are contributing code to these projects is quite difficult. And that's something that I think we need to take a look at. I mean, certainly this is no different than, inside an organization, companies who create proprietary software also struggle with this as well. And I hope most companies have a way that they can go back and understand, who wrote what software, which line of code was written and modified by whom. Because when you have to go back and do the forensics on a lot of this stuff, this is when this stuff starts to become pretty hairy. And so, we've had suggestions of creating common standards around identity across different software development environments that are widely shared by the world. Down to, should we have sort of a certificate authority type of attestation of identity in order to even participate in some of these widely shared development efforts. I think that is the most extreme end of that, but these are certainly things that, as this becomes more critical, we're going to see.
No, that's great. So I think that's a wonderful perspective. Now, Aparna, I wanted to touch on a point that you brought, which is extremely important, and it actually touches on one of the questions that was brought up by Divi in the chat log as well. Not everyone is bought into the world of open source and Git, and what's especially if they were going to listen to the conversation that we're just having in terms of the complexity of the software supply chain, the number of participants, the lack of attestation in many cases, this archaeological expedition that you're talking about, Jim, from that standpoint. So what would you say to people who are locked into the world of on-premise monolithic source code management, or don't believe, who have the syndrome of saying, if it's not built here, I'm not going to put it into our code. And Divi brought up that works for a utility company, and they do a lot of in-house production on applications and custom pod systems. The security team is against open source and believes in SaaS solutions as in-house hosted internally, but their business leads believe in open source and internal hosting. So what would you say to people that want to move to this world and are from the grassroots level within their organizations pushing it to counteract the security mindset, the mindset that it's fundamentally insecure when you move into this? What recommendations can you give to developers to this? What recommendations can you give to organizations? And then also, am I just wrong? Is this something that everyone's moving to, whether you like it or not? Is this just a fait accompli from that standpoint? So really fundamentally, for people who are reluctant to move, what do you say to them? And what are the positives and what are the risks that they may encounter? Or what is the opportunity cost if they don't?
Yeah, I think it's a difficult question to answer, but I think it's a very real situation. And I don't think the answers are actually anything revolutionary. One answer, I think, which, kind of enhances the developer point of view is that if you are missing out on using open source, you are often missing out on some key pieces of innovation that can push your business forward, right? For example, I mean, if you think about, technology today, containers are an open source technology. Orchestration of containers is an open source technology. Many of the languages are open source. Most of the developer tooling is open source. So open source is so inherent in kind of the modern application development that it's unlikely that there's a company that isn't using any open source. So they probably are already if they don't realize it. So the question is really, should we use additional open source and how do we get comfortable with using additional open source? And I think this is where it's really important to sympathize and understand the perspective of this organization, that is being referenced here. But by Nidhi, but I see many organizations, I would say, most large organizations have, are very stringent about what kind of code can be used. And many of them have a not invented here culture, especially the most engineering centric organizations have a not invented here culture. And I think that it's reasonable, actually. I don't think there's anything wrong with that. I think it is important to ensure that when you are a software provider or a software developer, whether it's for yourself or it's for external customers, you have to make sure that that code is up to your standards. Anything that you are using is up to your standards. So, and that's an issue, for example, for Google as well. Like, we have to make sure that anything that we are hosting or we are using is up to our standards. So how do you make sure that that is the case? I think there's many different mechanisms. I mean, if you have a strong engineering team, then they can certainly contribute to open source. They can contribute to building capabilities in whatever open source project your developers are interested in to ensure that it is secure. The other thing you can do is that you can bring in that open source project that your developers are interested in. Again, the developers have to make the case why it's important to the business, and why it would accelerate the velocity to use something in the open source rather than writing it from scratch themselves. And that shouldn't be too hard to do. But once that case is made, then your platform team should, have the incentive to go out and bring it in and, make it your own. Do the testing on your own infrastructure. Make sure that you have tested for the most likely cases. And maybe you try it in a more controlled environment with a lower threshold for disruption to customers, and over time you evolve it. Now there's going to be some bugs that'll come up for sure, but if you have a team dedicated to addressing those, then that's kind of how you'll operationalize that software. So I think for organizations like the one Nidhi is mentioning, they typically have a fairly advanced engineering team, and I think it makes sense for them to be cautious and to go through the full process of really making open source their own.
Wonderful.
Yeah, I mean, did I hear it was an energy firm that was?
Utility company.
Utility company. Yeah, I mean, I mean, there's some tough news here, which is, you're between a rock and a hard place here. And I think that, if you look at, the SCADA systems that are being deployed in a lot of these utility implementations, you've got insecure design, you've got all these heterogeneous protocols and a mishmash of random database. I mean, this comes from, sort of government research that looks at this infrastructure and is trying to help us prepare for that. I mean, you can't really stay there. And then, almost all modern software is written using a collective set of assets that are largely open source, because you can't just go rewrite an operating system from scratch in almost any case and meet the demands of, a smart grid that is an incredibly complex thing to do. We're working with a consortium of European utility providers who are already using open source and open sourcing all of their smart grid management tooling. The key is to make sure that you're responsible and use the process that Parn set up, work with vendors like Google who are supporting secure coding practices upstream, developing standards across CI/CD pipelines like Tecton, in order to make sure that modern co-developed software that's eventually integrated, and the responsibility is for the person who's actually deploying it, that all of that is done in a secure manner. But I get this question all the time, and usually the answer in almost every case is you blocking open source was a thing you might have done 10 years ago. It's just too late. You're already dependent on this stuff. The answer is like all challenging things, complex, and requires diligence and understanding of what software are we going to depend on. Let's make sure we understand that that code is coming from secure places, that's written in a responsible manner. And you have organizations like ours working with the leaders in the industry to help assure that across the global software supply chain. So I don't think there's a put your head in the sand and just use in-house software approach that works for a modern utility company.
Yeah, I think that's a perfect segue into our last few minutes here. And let's you guys being the experts and having access to the experts. So I think whether people realize it now or they will soon, I think what you guys are saying is 100% correct. There is no hiding your head in the sand anymore. So now that said, let's get prescriptive for a minute, and then we'll look at big picture. But prescriptive from a standpoint, let's say I am a security professional in an organization, and I'm bought into everything that we're saying here now about the security, the software supply chain. Where do I turn to? There is, last check, when you look at some of the cybersecurity landscape, there's literally thousands of different companies that are out there that take different components of cybersecurity, of course. And then a subset of that is going to be around the software supply chain. Now, obviously, you can't name every single portion of the solution. Is there some place that individual could turn to for a reference architecture in terms of how they should tool security around their software supply chain? Is there any place yet in which people don't have to start from scratch, so to speak, to be able to architect their security platform around this software supply chain? Any recommendations you can point to that is prescriptive to the people listening?
Sure, I can try and go first. Well, first of all, I think you have to look at what industry you're in, right? I don't think there's a common answer for everybody. So depending on the type of industry you're in, you are facing different types of regulations and different types of requirements. So generally, I think what is important is to, as an IT team, work with the lines of businesses and development teams to understand what's coming down the pike in the next 2 or 3 years. What type of applications are we going to want to build? What type of new areas are we going to want to go into? And what type of software are we going to need? What kind of velocity are we going to need? What type of development process are we going to need? So once you know that, and that may involve, moving to cloud, maybe using multiple cloud vendors, maybe having a hybrid environment, perhaps involves certain types of languages, perhaps it involves certain types of frameworks. Having an assessment of that as a centralized IT organization is very important, so that you can then have a roadmap that says, I'm going to provide these capabilities. And in providing those capabilities, you're going to certify certain providers, whether it's Git providers, whether it's and then I would, most customers are building a security framework around that. It's typically the SecOps team and the NetOps team that is involved. And if you're moving to a hybrid environment, then what does that architecture look like? So typically, it's something that every company does for themselves, but there are certainly, many models out there. From a Google perspective, we have blueprints for how to set up your network architecture, how to set up your your security posture, depending on what kind of requirements you have. So for example, if you're in healthcare, you have certain compliance requirements. If you're telecom, you have certain, if you're in retail or financial services, you have PCI compliance and audit requirements. So there are blueprints, and there are clear documents, as well as existing, sort of templates that you can just deploy that'll set up the network in the right way. It'll set up the correct network, security policies. And then beyond that, there's some level of flexibility in terms of what tools you use. We have something called the Security Command Center, where there's recommendations and you can choose which tooling you want. So I think it's industry specific, and it has to be designed with the needs of the organization in mind, but there's certainly blueprints available.
Wonderful. Jim, any thoughts on that too as well?
I totally agree. I think that, it is very industry specific. The financial services industry has a set of regulatory requirements that are very different than, the film and entertainment industry and the retail industry or telecommunications sector. So I agree with Parn. I think it is very specific. I think there's some general frameworks that you can use to understand these issues. Kim put a link into the openssf.org. I think this is a really good resource to see what is going on in terms of the software supply chain globally, emerging standards around software bill of materials, work groups that are addressing a lot of these issues, peers in the security sector that can help with cybersecurity issues and secure coding practices. I also linked to a free class on edX that came out of that initiative. That is on secure coding fundamentals. So those are a couple of just baseline resources. I think, Ajay, when you think of the tools industry and what's going to work in your environment, probably the top thing that I would look at is what is going to be in line most efficiently with the developer experience as people are writing code. This is what sort of separates these companies from each other in the security tooling space in particular. Those that are really well aligned and the least intrusive to the developer experience are the ones that actually get used. Otherwise, developers are super clever at subverting this stuff if it's just getting in the way of their development velocity, which for a reference, people are under huge amounts of pressure to get that code released and to continue that velocity. I mean, I was looking at our Harvard research here in terms of, what percentage of hours do you spend devoted to the following tasks for developers: new code, improving existing code, maintaining bug reports, documentation, admin, new ideas. I mean, security is so far down this list. It's just insane. And if you can somehow create a developer experience friendly set of tools and adopt those, and there's a bunch of commercial providers. I know the Blue Bracket product is something that really respects that well. Those are going to be the ones that will be effectively utilized by your development teams and maintain that development velocity you need.
Right, that's great. Let's remember why we were here in the first place. We're talking about how we enable the software supply chain and make it easier, and security shouldn't be an impediment to that. So this has been a absolutely wonderful discussion. I want to thank you guys for taking the time to be able to do this, and our hosts at SignalFire. But now, just one last question for you both, maybe with you, Aparna, starting. What are your closing thoughts? What is, if you have to distill it down to the top thing that you'd like people to remember about our conversation here, what would be the thing that you want people to walk away with? Perna first, and then Jim, some closing thoughts from you as well, please.
Well, I think the biggest, most important thing to take away is that developer velocity and developer productivity is at a premium because it directly impacts your business performance. And security and operations are often at odds with that, but it does not have to be that way. In fact, the most successful companies make sure that security and operations is built into the developer tool chain by default so that it doesn't slow down development. And it's very possible to do so. There are some really great techniques that are available, especially in kind of modern software development. And I would encourage everyone to look at, enabling a faster supply chain, using containers, using some of the modern development processes with Git that have a built-in capability, and to start to experiment and use those.
Wonderful. Jim, closing thoughts?
I mean, I couldn't agree more. Just bite the bullet. You got to get onto a modern software tool chain, right? Like there are so many good ways to quickly produce much higher quality, more secure code that is being collectively audited from the most successful software companies in the world. Like I just 100% agree with Perna. Like that is, you can do both things here, but you have to do it with intention. You have to understand at a basic level how code flows in and out of your organization and globally. When you understand those things, you can then go look at how your software is being produced, understand if you need to upgrade to more modern development tools that can achieve both velocity and secure coding practices at the same time.
Wonderful. Developer productivity enabled by security, not as in spite of it, where security is an impediment.
That's
Very
right.
well stated, guys. Thank you so much. I want to thank you guys again for spending the time with everyone. Really appreciate it. Michael, I'm going to hand it back to you. I want to thank you guys at SignalFire for hosting the event as well. And maybe you could talk about how people will be able to find this recording and how we can share it with our peers, et cetera. That would be very helpful. But thank you so much, Michael.
Certainly. Yeah, thank you all so much for participating. What a great conversation. Loved hearing about all of it. So we will be, our team will be sending out an invite with notes from the event, as well as a link to the recording of the event. I'll probably send that out tomorrow. In addition to that, the Blue Bracket team may be reaching out to some of you as well. And Jim and Aparna, same thing. If you want to reach folks that attended this, you'll have the RSVP list too, and feel free to either send them notes. I'm sure they would be happy to hear from you, or just send us a note and we can help facilitate. But again, thank you all for joining. If you have any questions specifically, you can just ping me once we send out that follow-up email. But otherwise, hope we'll see you at some of our future DevOps events as well. So thanks again and have a great weekend. We'll talk soon.
Thank you all.
Thanks
Okay,
everybody. Bye now.
Thank you.